Okay, so here's a solution of a question which I gave in class but didn't solve. Okay, consider two gases at 22 degrees Celsius, hydrogen and helium. Hydrogen, gas, helium, gas, right? Diatomic, monatomic. Why? Calculate the temperature. All right, so 22 degrees Celsius, 22.0 degrees Celsius, and it changes to kelvins. We've got to go 22. My intro, this is page 16, by the way. I had a question in class today. Are we using 273 or 273.15? Page 16 says we're doing that. Page 23 describes how to add these two numbers. See all the examples that he gives us. He doesn't use 22.0. He just uses 22 or whatever. Just goes to the ones place. The examples that I see in the text. So please consider reviewing those pages intro if this doesn't look familiar. So the way we add these two numbers together is we add everything up, 592, and then we go to the lowest degree of precision and round to that point. So this is 295.2. All right, so let's go back over here and say this is equal to 295.2. 295.2. All right, and let's see, calculate the root mean square velocity. All right, so we look up in the book RMS is equal to square root 3 RT over molecular mass. The molecular mass, or the molar mass, and the molar mass is in, when it's a capital M like that, is in kilograms per mole. So R is equal to 8.314 joules per mole Kelvin. This is in kelvins. T, we already got T. And M. All right, so instead of getting M first, I'm going to do formula weight. So the formula weight, the atomic mass of hydrogen is 1.008. So the formula weight of H2 then is going to be 2 times 1.008, which is equal to 2.016. 2.016 grams per mole. But we need this in kilograms per mole. So I'm going to put 2.016 times 10 to the negative 3 kilograms per mole. And now I'm ready to do my root mean squared velocity. Okay? It's equal to 3 times 8.314 times 295.2 divided by 2.016 times 10 to the negative 3. All right, this is going to give me meters per second because I cancel everything out and get that. The meters per second is not under the radical. All right, and this is going to give me 1. So I got from that 1.911 times 10 to the 3 meters per second. All right, so over here it's something very similar, 8.314, 4.003. I don't multiply this one by 2 because it's not a diatomic molecule. And this goes to be 4.003 times 10 to the negative 3 kilograms per mole. And this then goes to be 3 times 8.314 times 295.2, 4.003, which is equal to 1.356 times 10 to the third meters per second. Okay, so that's the root mean square velocity of each. That's the first thing we did. The root mean square velocity of each. Now the second part, let's get rid of that and come here and say, oops, I don't want to do that. Let's find the ratio of the rates of effusion of hydrogen to helium. Oh, by the way, hydrogen to helium, the rates of those ratios is going to be this: the rate of H2 over the rate of He. Okay, so this is going to be the molar mass of He over the molar mass of H2, which is going to equal 2.016. Oh, wait. No, it's helium was on top. So it's 4.003 over 2.016, which comes out to be 1.409.